Hello students, welcome to 10-minute lectures YouTube channel. So today we'll be discussing about the number system. We'll be going through what a number system is, what are the various types, and the basic conversion from decimal to various other number systems. So let's begin. So as an introduction, what is number system? Number system is a simple representation of some numeric data, that is digits, that is used to carry out data manipulations. As far as the computer is concerned, various data manipulations are carried out inside a computer in either form of the number system. Maybe it is in decimal or hexadecimal or binary. Okay, assembly languages are usually hexadecimal. What we give as an input is octal or decimal. The actual processing takes place in binary. So there is a requirement of conversion of one number system to the other. So let's see what are the various number systems and what is a base of a number system. So first one is binary. In binary, as the name represents, only two digits are used, that is 0 and 1. So the base is 2. So binary is always represented with the base 2, that is 0 and 1. Next is octal. Octal is represented using 7 digits, that is 0 to 7, and totally 7 plus this 0, that is 1. Totally 8 is the base of the octal number system, that is 0 to 7 including 0, that is the base of 8. Next is decimal number system. It has a base of 10, that is 0 to 9. 1 to 9 is 9 digits, plus we have this 0, so totally there are 10 digits. Hexadecimal, as the name suggests, decimal is 10, hexa is 6, so totally 16. 16 is the base of hexadecimal. And here we have 0 to 9 as in decimal. Then we have A to F. A to F is represented in this way. 10 is represented using A alphabet, 11 is represented using B, 12 is represented using C, and so on. 15 is represented using F. So totally we have 10 plus 6, that is 16. So this base is important for the representation of the number system. We'll learn how. So at first let us see about the decimal number system. Decimal number system is the number system that we use in our daily life, whether it is cash or count or something, we use in decimal number system. So it is a combination of 0 to 9, as we have discussed earlier. So as we are discussing decimal as a main topic today, we'll be going through the various conversion of decimal to binary, decimal to octal, and decimal to hexadecimal. So let us learn it one by one. So at first, decimal to binary. So decimal to binary. So in the question paper, you will be provided questions like this: convert 179 to the base 10 to binary. So this base 10 represents that this 179 is given in a decimal number system. Okay, so this base, it is important for you to be aware of this base. So 179 here is given in decimal. If this base would have been 8, then this would have been in octal, though 9 is not valid there. If this would have been in 16 base, then this would have been in hexadecimal form. Okay, so as of now this 179 has a base of 10, so 179 is in decimal. Let's see how to convert it. At first, this is the simplest method that you can follow. There's an alternative method that we'll be discussing in our next slide for the conversion of decimal to octal. So this is the first method. What you have to do is you have to write a sequence from left to right in the increasing order of the power of 2. This is 2 power 0, that is 1. This is 2 power 1, that is 2. 2 power 2, 4. 2 power 3, that is 2 cube, 8. 16, 32, 64, 128, and goes on. Okay. Now when we convert 179 to a binary form, we'll be getting an answer in only zeros and ones. Now how we'll be getting is, what we'll be doing is, we have this 179 to be converted, and we'll be looking for a number which is just smaller than 179, not too small, just smaller. Now on the right hand side of 128 we have 64, which is too small. On the left hand side of the 128 we will be having 256, which is much bigger than 179. So we'll be taking 128, which can occupy exactly once in 179. Okay, so 128 occupies exactly once in 179. So we have put here 1 and we'll be subtracting 128 from 179. We got a remainder of 51. Next we have to compare this series with 51, which is a number which is just slightly less than 51. It is 32, because 64 is greater than 51, 16 is too small, so 32 is the number which is just below 51. So we took 32 once and then we subtract it. Then this loop goes on. We got 19 in the remainder, we have got 16 just below 19, so we'll be taking 16 once, we'll be subtracting, we got 3 as a remainder. Now 8 is greater than 3, 4 is also greater than 3, that is these two numbers will not be occupied in 3, cannot be occupied in 3 in fact. So we have 2, 2 occupies exactly once in 3, so we took once 2, so subtracted, again we got 1, we took 1 once. Now when we get the end result, it has to be 0. Okay, so this is the actual series that represents the binary. So this is the answer for binary. Now binary is represented using the base 2. So this is the simple representation of how a decimal can be converted into binary. Next is decimal to octal. Here what we'll be doing is, it is a simple fraction method that since the base of octal is 8, we factorize the given number using 8. So 8 uh, occupies 22 times in 179, remainder is 3, we have kept it here. Again 22 is factorized using 8, 8 into 2 16, remainder is 6, 6 is kept here. Now 2 is smaller than 8, so 8 cannot be occupied inside 2, so we leave it as such. Now what you have to do is, you have to write these remainders in the bottom up order, that is 263, that is 263. 263 is the octal representation of the decimal 179. So that is decimal to octal. It is simple, you have to just factorize the given number using 8, and the remainders you have to keep it aside. In the final result, you have to write the remainders in the bottom up order, 263. The same method can be used for binary also, only difference will be that you will be factorizing the given number using 2. Okay, and whenever you divide any number using 2, the maximum remainder can be 1. Okay, so only we'll be getting zeros and ones only in the binary number. You can practice that as well. So let's go to the next conversion, that is decimal to hexadecimal. Now the same method that we used for decimal to octal, here what we'll be using is 16, because the hexadecimal has got a base of 16. So 16 occupies 11 times in 179, so 3 is the remainder. So what we'll be doing is, we'll be having just two numbers, that is 11 and 3. Now as we know that 11 cannot be represented as such, and it has to be represented as B in hexadecimal, we just change it, we convert 11 into B. 3 is SH because 0 to 9 is valid in hexadecimal. So as we had already discussed, 10 is represented using A, 11 is represented using B. So we have got the end result as B3. So hexadecimal of 179 to the base 10, that is decimal form, is B3 to the base 16. So that's it about the conversion of decimal to binary, octal and hexadecimal. So here's an exercise for you. Please try it out. Please verify your answers. Answers have been provided here. And if you have any doubt regarding this topic, you can kindly mention it in the comments below. So for further queries, you can always mail me at 10classes@gmail.com. So if you like this video, please like and subscribe to our channel. Thank you.